He came in all the way from Singapore. So big round of applause just for that. So good to have you here. Before we get into the ecosystem, help us understand what is DBS, what is the mission, how do you guys operate that's differentiated and unique from any other bank around the world?
The whole concept of DBS Bank is bankless, basically. So make banking something that you enjoy, right? That's the mojo. And to do that, we need to make it simple. Simple that it's like a utility. You just pay for the service, it's just there. I think some of the unique differentiators in DBS is that the corporation truly believes that we're a technology company. And by saying it, you don't really do it. You actually need to do it so that you can say it. So DBS today is around, we're close to 50,000, 23,000 are native developers. So almost 40% of our bank are developers. Around close to 50% we're a contributor to the open source world. So we're very connected into the open source mission. We have important roles to play with hyperscalers. We drive some of the product roadmap and engineering in AWS. For example, products that were released last year that you can report to, data zones. We created a concept in DBS called AWS Workspaces, which that turns to be actually AWS data zones today for the open market. We drive some missions with Google, same. With Microsoft, we do the same. We test a lot of the Microsoft AI ML portability to see if what they runs on the cloud, runs on-prem, vice versa. So yeah, in general, the bank is quite interesting because technology is in the DNA from the top. I probably, in all the years in IT, I've never seen a CEO so technical in my life. Our CEO, Piyush, can go down to the fine level detail of what a data fabric is and how it works. And his philosophy 6 years ago when we started the data journey was, we're going to be a data-driven organization 100%. And that's how the story of ADA, which is advancing DBS with AI, started. Actually, the name of Ada comes from Ada Lovelace. She's a mathematician. She's actually considered one of the pioneers of machine learning. So Ada, that's how it came to be. And today, it's quite interesting that Ada is almost a footprint that we see replicated in many other areas in ASEAN from ex-DBS employees.
Yeah.
They're actually hired somewhere else and they take our concepts and try to do it on their own on the other side. So yeah, I think DBS is an interesting bank. It's quite interesting in general. But yeah, that's what I can say.
Fascinating. 23,000 developers out of a total of 50,000 employees in the company.
Yeah.
Wow. I don't think companies have more than 5, 10, maybe 15% of their employees being developers. And then 50% of those developers are open source committers.
Yeah.
That's incredible. There's a lot more to learn there. Before we get into technology, what are some data outcomes, some data products, some data analytics that you guys are proud of? Maybe they're revenue generating things. If you can get us a little bit of insight into some of the use cases that data is driving inside the bank, inside the technology company.
So I guess everybody's familiar with cloud, so I'll start there. There's many ways to do cloud, but there's also the banking way to do cloud. And finance is ring-fenced by regulation all over the world. And to do cloud in ASEAN is quite complex because we do have data locality and restriction. So we don't get to choose the cloud. Sometimes the cloud chooses us. So Indonesia is a perfect example. We call it, one year too late is the story. We promised ADA capabilities in Indonesia. The only cloud available is Google Cloud. We're going to have to learn how to do Google Cloud, right? We call it 1 year too late because 1 year later, AWS created their first pod, right? But we already had the investment, we were developing on it. China, we have the same problems. We can't take data out. There's no hyperscalers there other than Chinese. Tencent, Ali, Huawei. So you got to learn and get into it. India has now new regulations, new data restrictions, move all the data to India, all the compute, all of it, run it from India. So now that created a complexity for us. How do we orchestrate data from a central governance place and run and computing the edges in Indonesia, China, etc. So Evolve became a mission. Evolve is an overlay that we have on the cloud on how we ring fence all the compute, storage, services, and every resource that cloud provides. If it's not whitelisted through Evolve, it's not available. So Evolve basically it's a control plane of what's provisioned on the cloud and what's not.
That's proprietary.
Yeah.
DBS stack. Yeah.
So we've already sold Evolve to other banks. The reason we did that is because also there's a lot of, I would say there's a lot of silly mistakes when people use this cloud. Sometimes they go and explore, they provision, they spin up some SageMaker notebook and mount GPUs and they just keep it running and never shut it down. For us to provision a SageMaker notebook, it's through our marketplace. So basically, if you want to deploy resources on cloud, it's through all cloud formations, similar like AWS. It's all infrastructure as code. So either you know what you're doing or you don't. So if you don't, you cannot use cloud. Have a good day, right? And that's how we create a protective mechanism. We also we've created many products, but we haven't sold all of them. The reason we create our own products too is because we've been let down way too many times. And it's the world we live in, and we accept that. Our data protection mechanism back then used to be Blue Talon, which then was acquired by Microsoft. And Microsoft then decided to dispose the product and use their own product. So our entire security framework relied on Blue Talon. And now we need to negotiate with Microsoft a brand new contract. So it was like, either we do it, and we said, you know what, let's just build our own. And we just went in and created Arculus, it's called. And we built our own mechanism, right? So in a way, DBS protects itself from being forced to just do what the providers want us to do, right? There's a resistance from us to oblige to that. and it's a big resistance, right? I want to say today that our data platform, our biggest competitors are Databricks, Snowflake, the Nodo, the Taiku. It's not other banks, right? And why do we think that way? Is because if we don't prove the value of our own data platform, the simple decision is let's just go buy one, right? So I was talking this morning to Unravel and some of the CAP peers that the way we see it is three ways. I took the analogy of cooking. You could be extremely on the right-hand side, which is home cooking. You go buy your own ingredients and then you cook at home. On-prem, 100%, and you build your own stuff and everything is done that way. On the data side, you could be on the extreme left, which is, I don't want to cook my own stuff. I go to a restaurant and then I see a menu and order from it and just eat the flavor of how it comes. The way we see Ada as our data platform, we actually see it as a cooking studio. We provide the kitchen. You can pick the ingredients you want, and then you can cook the recipe with your own flavor. And that's what we provide to our lines of business, right? The good thing about it and the bad thing, the good thing is we can plug in anything new at any given point in time. And the downside of that is that you do require very, very good technical people that, for those that don't know Singapore, it's quite limited. It's only 5 million people. Competition
half of which work at DBS, obviously.
Yeah.
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 There's a lot of competition for talent. So we had to look for talent everywhere. We got, of course, we got delivery centers from India. We have delivery centers in Guangzhou, China. We got delivery centers in Poland. This is just for engineering work, not for banking, because that's where we find the skills for data. So for us, it's been quite a journey on how do we build that thought leadership into building our own products and sustaining the pace of rebuilding new products, trying to keep the pace with the open source side, which moves astronomically fast, and at the same time keep our customers happy. So yeah, that's.
It's a bold decision to go open source, and not just open source, but then build your own layers and proprietary technology as wrappers for governance, for control plane, for data plane, for everything that you guys have built so far. But you also buy technology, like Unravel is one of the technologies. Starburst is another one that you guys are using right now. So how is that decision made then in a company that is aligned with controlling your own destiny, building your own products?
So the answer to that might seem too complex, but it's not. You need to ask yourself whether the product that you're bringing in from an enterprise grade, is it going to drive the core on what we do? Is it the spinal cord of what we do or not? Or is it a complement to what we do, right? So Unravel, we've had Unravel for a long, long time. It's one of those products that we said, should we do it? Or should we find something in the market? Unravel was so niche that it was an easy choice to say, if they can do what they say or claim they can do, bring them in. We don't need to develop our own stuff for that because we're already planning it. And long story short, the fact that you guys are still with us demonstrates that there is value from the lines of business, and they consider there is value in the product. We are not the users of Unravel. The users of Unravel are the business units that are creating their jobs. We just make sure that we drive enough adoption that everybody in the bank would use it. Because ultimately, our data engineers cannot overrun a troop of 3,000 data scientists doing, funky stuff, to put it in a way. So we gave the tool to them. They can use, optimize, and control their own fate. Products like Starburst are very similar, right? Starburst is not, it's a core component of the data platform, but it's something that is easily decoupled from the data platform itself. Why do I say that? Well, it's not how we define our metadata. It's not how we ingest the data. It does not provide the security, the anchor points, the tokenization methods. It doesn't define any of that, right? So we keep very open the what we call our spinal cord. Babu was asking a question that I didn't want to answer at the time, which was Spark and Kubernetes versus Databricks. I'll tell you what the downside is first. You really need very smart people to manage a Kubernetes cluster. How do you run an Istio network? All of this stuff is not something you learn in literature. I'll put it like that. So you're going to get it wrong 100 times before you get it right. But we believe there's a lot of value into that, right? And goes back again to what we want to control.
Yep.
Right. We want to control. We want to give ephemeral capabilities to our tenants. We want to give them the ability to spin up their own ETL and shut it down when they want. And we want to be able to set our own policies and rules on how that operates. I can't do that with Databricks. I need to oblige by the restaurant rules, what the recipe is, right? So that gives us all those capabilities. So on one side, yes, there's a lot of technicality, a lot of engineering that goes into it. But if your organization is willing to go with you, then, happy days. We just go and do it, right? But yeah.
That could be its own conversation, right? Just Spark and Kubernetes and the battle scars.
Oh yeah.
Lessons learned and where you guys currently are. So switching gears, talking about team for a second. Describe to us one of those, we don't even call it full stack, but the unicorn roles that you have inside your team. Explain to us the why, and then how do you get them to do those kind of roles?
So I'll start with the most interesting role we got is something we invented, but it actually comes from the hardware days. In hardware, you have something called system performance engineers. And they're dedicated to optimize and tune how a processor operates. Does it do the right computational elements? How a chip is partitioned into multiple smart multi-threading, and they tune until, let's say, it's pristine. So I said basically, why don't we apply that concept and bring it over to data? What do we need? I need a very good data scientist that is exhausted of doing data science and wants to learn data engineering. And I need a very exhausted data engineer that wants to turn into a data scientist, because I need to connect and marry both worlds. It's the only way that a person can actually say, oh, this is why Pandas doesn't work on Spark. I get it now, right? For a data engineer, it's very clear. For a data scientist, it's not, right? Why? Because that's what they learn in college. In Coursera or Udemy, the first thing you learn on Python is Pandas. And they love it. And Spark hates it. It's a perfect divorce. So we need to teach data scientists how to break their Pandas into Spark. So system performance engineers became basically masters at doing this, right? They use Unravel for highlighting all the data points that you saw there. But then very fast they pick up and say, those are the data points we need to attack on that code. So let's just go see it, right? Data jobs are, we call them mutants, because they mutate from the hands of one data scientist to another. And you can literally see the differences on how they write the code. Some of it might be perfect with markdown files, explainability, the whole thing. And then there's an entire chunk of code that doesn't have that. And you're like, oh, okay, what happened here, right? So we tune and optimize the code. So again, applications like Unravel just help us facilitate the journey on how we can derive to what to do first or what to attack first from the optimization perspective.
Last question, Luis, before I open it up to the crowd, because we've got all the cloud providers over here. They're going to ask you questions about why you didn't choose them. So we'll leave a few minutes for those questions. Out of everything that you guys have created over these last few years, or half a decade or more, what's the most proud product or thing that you guys have done?
I don't think one thing is mutually exclusive of the other, but what makes us really proud is, I think there's two things that I'm gonna say. Item number one is we've been able to give the same vanilla flavor of using our data platform regardless of where it's running. And that sounds easy, but we don't believe in moving our stuff to the cloud. So we actually build everything native. So when you build everything native on AWS, you're talking EMR, SageMaker, SageMaker Jumpstart, all these different things, Redshift, and then you build a data platform there, and then you need to overlay that with a UI UX that makes him feel it's the same place. We've been able to do that in Google too, and on-prem. So for the data scientists, they're not really aware what's running behind the scenes, right? And that's
and they shouldn't.
Well, they shouldn't, but there are different. There's slight details into that.
Of course.
Like, for example, you're running SageMaker. SageMaker is running a specific version of Python, Py 3.9, and then you're running that, and then you're running on, Vertex AI, and Vertex is running other versions and other libraries, and then you're running CML or CDSW on-prem, and that's all running on custom engines and all this stuff, right? So what options are available dynamically to what the people is actually using is what you need to play with, right? Not everything is available for everybody. So that's one of the areas. The second area is our data plane. Most of the companies today deal with a lot of complexity on how data is moved, managed, and orchestrated. So our data plane is our transport mechanism on how data gets moved cross environments, meaning UAT, QA, prod, analytical cluster, cross clouds from on-prem to AWS or to GCP or to whatever environment comes next, and cross countries. All of it orchestrated from a central place that still contains, manages, and persists metadata and the data integrity across the board, so that we can guarantee that, you know, the data is interpreted in the same way, and we can still apply our own rules to prevent mechanisms such as, like you were talking about, data duplication, right? So for us, when you ingest data, that's what we call T1, which is kind of like a data lake. It's the golden source. It cannot change, it cannot be overwritten, it cannot be deleted, and it cannot be cloned. It's our own rules. That data is golden. You can consume data sets out of that and build new data frames on a data warehouse, different data warehouses. But that's a new data set, right? And even data warehouses have their own rules. And then you have the data marts, which is, you might need T1 tables with T2 data warehousing, do a combination of the latter, and you build T3, what we call our feature mart, right? So yeah, data plane, and of course, you know, definitely the way we do some of that stuff is
such cool stuff.
It's quite interesting. Look, in general, there's no right or wrong, right? Sometimes we're more wrong than right. But ultimately, you know, after 5 years of pushing across,
but it's your wrong. You can own that wrong.
Yeah, that's the beauty of it.
Yeah.
I don't depend on you know, specific products and where they're going. We don't. We can decide to bring a product or not. Like today, we're fully evaluating the Microsoft AI ML Studio deployed in OpenShift on premise, because we believe there's a lot of value into OCR, speech to text, text to speech, etc. But we also have those capabilities in AWS with Translite, Poly, you know, Recognize, all of this. We also have that, right? This is another flavor. And then Vertex Google has the same flavor too, in their own way, right? But you see, when we pick and choose the products, you say, well, if you have AWS and if you have Google, why are you testing Azure? Well, Azure gave us a mechanism to run on-prem disconnected containers of the flavors of what they have on the cloud, right? And because we have hybridity and multi-cloud, for us to be able to run it on-prem is quite useful,
yeah.
Right? And believe it or not, a lot of the hyperscalers that we deal with, they get it. I have another example. We tested a lot of AWS Macie for DLP. It's not that Macie didn't work to the extent of what we needed to do. Is that if I wanted to scan data, I needed to send everything to AWS and then turn it back, because I have no mechanism of running Macie on-prem, on Google, or some other cloud. I just need to do it on AWS, right? Google turns their head on me and say, you know what? You can run my DLP container anywhere you want. And I run a DLP scanning from Google in AWS, on-prem, and on Google, right? Because it fit the bill, right? So the fact that we control our own fate makes it very dynamic for us, yep, of what we can actually bring in and take out. So anyway, I hope
thank you for sharing
this has helped some.
Really interesting stuff. Thank you.